Hello everyone, welcome back to the part 4 of fine-tuning of a large language model. In the previous video, we have set up a Hugging Face account as well as established the connectivity from the Google Colab. But in today's video, what I'm going to do is I'm just going to explain each and every step in as much as detail in a simple word so that you can understand all the complex concept of the fine tuning and you should be able to just run the fine tuning by yourself. So I just picked up a new very simple model which I can just quickly show you, which is distilbert, which is a very simple, but we know that it's a bidirectional encoder representation from transformer, and distilbert is a much smaller model by just removing the redundancy of data of the basic BERT model. So you don't have to worry about all these things. All you need is this distal-based model uncased, right? So what all things we're going to do first, the very first thing which we're going to do is we are going to just define our task, which is text classification. Based on the text we are feeding in, we are going to just see whether it's a positive or negative, right? So our task is just text classification. So basically, if it is a text classification, then I explained in my previous video, for text classification, this is the structure or format in which we have to just build our data set. So this is a simple JSON where text has to be a tag and then the corresponding, the content, and then what is the label of that, whether it's a positive or negative, right? So this is what the data preparation. Then we're gonna understand how to initialize or the set up a model in a tokenizer. Just do the data preprocessing so that we can just convert the data into the format which model can understand. Then we're going to define the training configurations. We are going to write a very simple evaluation matrix with the scikit-learn also, which is very straightforward. I'll explain that. Then we are going to initialize the trainer and start the training. And once the training is done, then we are going to evaluate and do the some very simple testing with the text by seeing whether the classification is happening correctly or not. And eventually we are going to save and load the model, right? So let's quickly start with the library that I have already explained in the previous video. Like these are the library which we have to install, right? And then there are few bunch of the imports which we have to do. First is start, just to confirm whether the CUDA is enabled correctly or not. Then this is the main transformer library from Hugging Face. Auto tokenizer is to just detect the the correct tokenizer for the model which we are selecting. Since we are selecting a model which is distilbert-base-uncased, so we are using this class, which is auto model for sequence classification. This is a magical class under the transformer, and this actually automatically detect the architecture of the model which we are targeting, right? So there is a very general rule, like what class to be picked. So there are multiple classes like auto model for sequence classification, auto model for masked LM, auto model for the casual LM. So this is actually what it does is automatically load the final layer of our model by identifying the correct architecture based on the task and the model which we have chosen, right? So it does a lot of under the hood magic, so we don't need to worry about that. But this is the rule on the basis of which we have to pick which class to be used, because you will find that different tutorial series are using a different classes. That is specifically because they have chosen a different task to be done. Training arguments. Okay, how to define a training argument? What is training argument? Training arguments are actually control the fine tuning, and this is how it actually looks like. So there are a lot of things which would be familiar to you. For example, this number of epochs, and per device train batch process batch, just to utilize the resources more optimally. We will understand all these, right? Then trainer, it's just a training module which is going to allow us to train the model. And this data collator padding is actually just to have a dynamic padding rather than having a hard coding. Dataset again is the Hugging Face library, which actually gives us this dataset class to which we can just convert the data into the Hugging Face format. Pandas, NumPy we are all aware of. Scikit-learn we are just calling because we want some matrix related stuff. WhenDB is weight and bias AI platform. This is how it looks like, but this is not something which we should be worried about for now. Probably once you have a more grip on the concept how to do a fine tuning, then probably this platform will be helpful for you. So let's start with the data preparation. So what I have done here is, this is the structure which I explained. Why do we need only in this structure? Because our task is the text classification. So these are very simple, 5 positive and 5 negative. Positive is being represented by 1 and negative is being represented by 0. So this is kind of a supervised learning where we have an input and we know what should be the output. So these are the 10 records and I'm multiplying by 100 so that we're going to have a 1000 records, right? So I have already run this cell to have an import. Let's quickly run this one. So we have 1000 and now what we are doing, I'm just loading this data, which is 1000 records in a list with the pandas data frame. And then 80% I am assigning to the training data, 10% to the validation and 10% to the text. It's a very simple Python code where we are just calculating the 80% and 10%. Based on that, we are just splitting the data. So let's quickly run this. Now we reach to the point where we have to initialize or set up our model. So model name is this one. I have to explain you from where you can get this. Model name is same what you have in a Hugging Face. You have to keep in mind this has to just same name what you have here. Okay, once you have that, then you have to call this auto tokenizer, and there is a method inside this class is from pretrain, and all you need to do is to just pass the model name, and automatically this class will assign the tokenizer object to this with the correct architecture. Next one is how to initialize the model. So as I mentioned, auto model for sequence classification, we have to use this class. Method is going to be same. We have to feed in model name. Number of labels, since it's just a task classification with positive or negative, means 2 values. So that's the reason we have number of labels 2. ID to label is actually we want a numeric representation to the human readable format. So we have to given this like 0 is representing negative, 1 is representing positive. Then we have label to ID. This field is actually being used just to convert a human readable text into the numerical representation so that the machine can understand that. Let's quickly run this. Okay, it is going to take some time and it will just quickly done. Okay, now what we need to do next, you have to see how many parameters we have, right? All those information you can just in a Hugging Face also you can just figure out how many parameters it is trained on, what is the distill version, what is the main version. I think this is the master or the teacher model, and this is the student model, and wherever we have the student teacher relationship, we call this the distill model, right? Okay, so now in data processing, we have this function. What it does is take that tokenizer object where we have to feed each and every record. Truncation is just tell once you reach to the maximum length for any given record, you have to truncate that. And if the length of your record or your text is less than maximum length, then it has to be do the padding and then return the tens. Right? So this is what the tokenizer is doing. So what we are doing here is whatever the data frame we created for training, validation, and test, which is saved in train_df, val_df, text_df, which we have did here. We have to just feed into the data class in the dataset class of a Hugging Face, which has this method from pandas. It means we have to just feed in the pandas data frame, and we are just feeding in, the pandas data frame variable, which is train_df, val_df, and test_df. And then we have this data converted into the Hugging Face dataset form. Once this is done, then we have to feed every record into this function, and that is where I'm using this map method where we have to give the function name and where we have to say batches to, which is just to optimize the processing, right? So every record from this is actually going to feed into this function as an example, and this is going to create the tokenization, and whatever the output we are saving into the trained data set. And then we are removing an unwanted column because we have text as a column. So we are just removing that. So we have to just quickly run this. Okay, so this is how the data would look like. We have labels, we have input ID, and the attention mask, right? This is what the tokenizer is doing to convert our data set into the format, which is completely just representing the everything into the numerical form. Right? Now we have to define a training arguments. In training arguments, this is the output directory where we want to store the output of our fine-tuning process. Number of train epochs means whatever the training data set we have created, we have to run the 3 training cycle, and every cycle will shuffle the order of the value of the training data set so that it cannot memorize. So it's just a way how many times we want to run that. And there is a very recommended way. I mean, we don't want to get into that because those are the advanced topic, like on what basis we decide whether it has to 3 or more than 3. Same, this is just to optimize, effectively utilizing the resource. So I'm saying that, okay, per device, we have to just have a 16 record in one batch. This one is for the evaluation. Again, this is just for the optimizing that, but there are many more. And I have a very comprehensive documentation. If you are really interested, just feel free to reach out to me and I will share that, how to just understand all these training arguments and how it controls the fine-tuning. So it gives a very simple explanation for each and every parameter which you are seeing on this screen, and apart from that there are many more. Right, logging step and how frequently you want to log the once the training set is done, like I mean 10 training set is done, you have to log the progress. Same save steps, evaluation steps is like, okay, once you are done with the 500 training steps, you have to just do the validation, pause the training and just check the with the help of a validation set whether it is just improving the training or not. Warm-up step is just for giving us the learning rate. What should be the learning rate in case you want to just optimize the loss function. Weight decay is again what kind of changes you want to do in a weight. So these are the things which you can understand once you start understanding how the fine tuning happens, and once you start doing all these things frequently, then you will understand all these concepts. The next thing and the last thing which we have to do before we just initialize our trainer, we have to define a evaluation matrix, because that is one of the argument which we need to feed in when we are initializing a trainer. Right. So here, if you just see, we have this eval pred. I'll just explain from where it gets that, because this function is going to be feed into our trainer, and trainer intelligently internally calculates this eval pred, which is automatically get fed to this method. Right, so here if you see, I'm just using a scikit-learn method accuracy score on this precision recall F scores, and I'll just explain briefly what are those. So accuracy score is like, I mean, how correctly our model is predicting the positive and the negative outcome. Whereas the precision is, it's just an evaluation of the prediction of a positive outcome. Recall is where you just wanted to see how overall, I mean, based on whatever number of positive outcomes we have. So there is a very confusion between the recall and precision, but I have a very best example to just explain all these things in a very simple way. If you are really interested, I can just provide you the this document through which you can easily understand what's the difference between the precision and recall and what's the F1 score is. Right. So once we have all these things, compute matrix created, training arguments created, data set is done, model and tokenizer also initialized, all we need is now trainer. So in trainer, before we just actually use the trainer, we are just calling this class, which is data collector with padding, and whatever the tokenizer we have created, we are just feeding here so that the dynamic padding can happen depending upon if there is any inconsistency. Right, now the other thing is trainer. As I mentioned, that once we have all those entities defined, like initialize token, model and all this stuff, then we have to call this trainer class, where we have to feed in the model which we have initialized early, which we download, and then we have this training arguments. I explained this is just a way through which we are just controlling the fine-tuning process. Training data set and the evaluation data set, we understand. Tokenizer, I'm just feeding in a tokenizer. The data collector, which we have defined here, and then the compute matrix, as I mentioned, that's this eval pred is something which trainer is going to create and just feed to this compute matrix function. Right, so let's quickly evaluation. Okay, so we have run until this point. This is function, so let's quickly run this. Let's quickly run this function as well so that it gets registered. Okay, now let's quickly run this trainer. So we have initialized the trainer, and this is where the 1DB has to be done. Okay, so we are not going to do that for now. Let's quickly run this and see if actually 1DB actually gives us a hard time to do that. Okay, so let me just quickly copy and paste few things. Okay, so now the training will start. As I mentioned that the logging step, now we can see this. It's just telling the training loss. What was the training loss? And we should start seeing that earlier it was not pretty stable. Then it start reducing this loss, and eventually we just reduce to this 0.008, which is really good. Training completed, model saved. Now we have to do the evaluation and testing. So let's quickly just walk through this evaluation thing. Now we are using again the very simple default method, which trainer object itself, which we have defined here, is actually provides evaluate. So we have to just feed in the test data set, and we are just iterating through, because this is going to give us the JSON object, iterable object basically, and we are just seeing the key and the values, which is precision with a 4 decimal point, right? So we are just seeing that. And again, we have a more improved evaluation matrix as well, where we are just having this function where we are just feeding, okay, some of the additional, text which I have created, which we are going to feed into this function, and we are going to see, I mean, what kind of output we are getting. So if you see, if we have a text from our side, then we have to convert that into a tokenizer. So we are using the same tokenizer object, and then this is just a logic which is for the Google Colab. We have to just make sure whatever the tokenizer we have earlier defined, it is just only on the same device. So you don't have to worry about this piece of code. This no grad is telling you there is no need to train the model. It's just that you have to make the prediction and whatever the model we have earlier. So we are just feeding in, and with this torch no grad, it's actually just going to predict based on the input. And once we have this prediction, it is just trying to convert into these. It is actually just softmax function from torch is basically it's just giving the percentage in between from 0 to 1. So it's a way through which you can just predict, just create the percentage, and this is actually just taking all the predictions values and just taking the maximum whatever the maximum prediction percentage we got, and that is something which we are filling. So this is just a way through which we are just doing that, but this is not something which you should be worried about in this video for now. But this is how you can see the evaluation accuracy, which is pretty much awesome, right? And this product is absolutely fantastic. Positive, I hate this, negative. So this completely makes sense. Right now, we just reached to the point where we have just fine-tuned the model. We have just verified it. It really looks good. So what is the next thing we have? We want to just save and load the model, right? So what we can do, we can quickly run this. So here, if you just see, we are calling this model and save preterm. So what we are saying, we want to just save into this my sentiment model, and I have to just quickly check one thing. Make this. Okay, so this is. I was just saving. So okay, that's it. Okay, now we are just saving the tokenizer as well, because we need a tokenizer as well, because whenever we are going to have a new text, we have to just tokenize that before we feeding into the model to predict that, right? So tokenizer and model, these are the two things which we have to put it over there. Right, and then how we can just load this. So it's pretty much simple. Where we are saving this in my sentimental, so we are just again using the same class, same method, but this time rather than pointing to the Hugging Face, now we are just pointing to this, which is in our local on GoogleColab, and then this is my local tokenizer, right? And then it's just doing what we. So this is how you can just load the as well. So that's it from my side for this particular video. And if you just see, this is where your data is actually going to look like. Config JSON model safe tensor. Earlier it used to be in a PyTorch format, but now it is more secure, where we have this model.safe tensor. So all these are configurations. I mean, I'm not sure whether you are interested or not, but in this video, we can just leave this for now. Because I have a very proper documentation for all these things, because it's it's too much to understand. So for example, if you just see this my sentimental, so model configuration is in config.json. Then this is where actually, your fine-tuned model is. So model weights are here in this safe tensor. This is a tokenizer config.json tokenization vocab. And if you just click on that, this is just a configuration based on whatever the setup we have in the training arguments and different models, tokenizers, and all those stuff. All those things, if you just click, you can understand all those things if you are really interested in. But those are very high level thing. I don't think so you are ready for that. But if you already know all these things, you can just always go through these documentation and check. Similarly, here we have this checkpoints, we have runs as well. Whatever the runs we have in checkpoints, here we can see all those tokenizer config, trainer state, trainer args.bin, which is really important if you are really interested to understand what is this. Here we have all the documentation where it explains each and everything, training, argument just used, right? So I think this is pretty much it, which you need to know from the basic of the fine-tuning perspective. I hope this video actually clarify all the concept for you. I know there are too much to grab, and I know this video is too long, but this cannot be shorter, right? Because we have to understand all these things. Otherwise, we won't be able to, just do the complicated stuff with the fine tuning, because fine tuning is not the easy thing. It's really a complicated thing where we have to understand how those things are structured, right? So now that's it from my side for this particular video. In our next video, we are just going to see, once we have this fine tune model, how we can test that and how many ways are there through which we can test that. So there are various ways through which we can test that, right? So there are 7 different test methods which I tried to figure it out through which we can just do the testing as well, and that is something which we're going to cover in the next part. So that's it from my side for this particular video. If you have any feedback or suggestion, please feel free to put that into the comment section, and I would love to incorporate that in my upcoming videos. right? So if you really like this video, give a thumbs up. And if you feel this video can help your friends, colleagues, and groups, please feel free to share with them. And as always, thanks for watching this. Stay healthy and keep learning new things.